Good morning, good afternoon, and good evening. Welcome to the 8th installment of the Unravel Optimize webinar series. I'm Marissa Mendez, Field Marketing Manager here at Unravel Data, and today we are joined by Patrick Mawyer, our Unravel Data Senior Solutions Engineer. Today he'll be discussing managing costs for Databricks. Now, before I pass it over to Patrick, here are 3 housekeeping reminders. 1, throughout the webinar, please drop your questions into the chat and into the questions box, and we'll do our best to answer them live or via email if we're short on time. 2, we understand that life doesn't have a pause button, but this webinar does. So if at any time we need to pause or replay, this webinar will be available instantly on demand to listen at your leisure. And then 3, help us improve. Share your feedback on the session by rating this webinar and let us know if there are any other topics you'd like to hear about. All right, now that we've got those reminders out of the way, the floor is all yours, Patrick. Take it away.
Thank you, Marissa. Give me 1 second. Check this out. And all right. So I apologize in advance. I had some technical issues last time. I've gone ahead and turned off my camera, so you won't get to see my beautiful face today, other than on the next slide. So as a reminder, this is our Optimize series. Today we're going to be going through how you can utilize Unravel to manage costs on Databricks. Now, this is me, Patrick Mawyer. I'm a solutions engineer at Unravel Data. See my email there if you want to reach out after the presentation. I'm always willing to answer questions. Now, the topic, we're talking about Spark, and Spark is a hot technology. And when we think of Spark, most of the time we're thinking about Databricks. And that's because Databricks is a great platform that's accelerated Spark adoption. It provides simpler deployment options that allow you to bring things to the market faster. And that's through performance, speed, and scale of those Spark jobs that you are running on Databricks, which, because it's a cloud-based platform, is virtually infinite. Now, the point of this conversation really is, with the virtual infinites can come infinite costs if they're not managed properly. So we talk about the challenges with running these Spark jobs in Databricks. And some of those challenges to overcome is lack of governance and visibility, which can lead to unexpected costs. And another thing that can contribute to that is less expertise when you're working with these newer technologies. So you get developers into these platforms, it's a cloud system, they have more control over what they get to provision and running their jobs. And inefficient development can lead to higher unexpected or unwarranted costs, which leads us to that third point, resource inefficiencies. And ultimately, those can affect your customers more than lost time. Can introduce increased costs on the end product for your customers, or cost directly, if they pay for your clusters. So today in the session, when we talk about cost optimization, we're going to talk about various vectors of cost optimization. First one is job level optimization. So at the heart of this, your Spark jobs essentially contribute directly to what you're paying for in Databricks. So those DBUs that you're using to run those jobs. Optimize the jobs, you can optimize your costs. We're talking about cluster level optimization. So in Databricks, when you define your automated or your interactive clusters to run your various jobs, you can easily over provision for your jobs and essentially drive up cost, again, unwarranted spend. And then there's governance and visibility over your estate. And what we talk about here, which we'll demonstrate, is going to be the auto actions, the ability to essentially know before you get to the end of the month that somebody is driving costs too high by overutilizing DBUs, or running their applications too long in the clusters and hogging resources. And of course, after we talk about these 3 points, we're going to go into a quick demonstration on what this looks like in the Unravel platform. So the first, job level optimization. And this is where we're going to ensure that the jobs that you're running, that they are sized properly So basically, resource efficiency is what we talk about. It's top of mind there. Ensuring that your code is written to take full advantage of those available resources. So if you have skewing taking place, or you're spending too much time on a driver versus your executors, pointing that out, bringing that to the forefront so that you understand that without having to dig through logs and various metrics. And at the heart of this, at the end, ensuring that your Spark jobs and Databricks are running without fail, and being able to have the 360 observability of those jobs. So you think about today in the Spark UI, the Spark history logs, you'll have other infrastructure metrics that you might want to look at. Unravel is going to bring all of that into a single interface, and that's where you get that 360 observability. Cluster level optimization. So knowing when to leverage a proper cluster type. So if you're going to do automated versus interactive clusters, a lot of times now with scheduled jobs, you're going to typically go towards automated clusters, but understanding when those jobs are running, how often they're running, and making sure they're not impacting others in those interactive clusters. Knowing when to use elastic compute features. So this gets right back to that heart of that matter, is automated clusters, and making efficient use of, only paying for what you need. That famous mutual company, only pay for what you need, right? And then understanding when to use those all-purpose or persistent clusters. So this is when we talk about those interactive clusters where you have shared resources and potential resource contention. And so now we talk about governance and visibility. So this is where we want to understand who's abusing resources, running jobs that are too long and taking up precious resources in that interactive cluster, or maybe blowing through our DBUs and essentially contributing to cost overruns. Understanding where the spend is going. So, excuse me, giving some insight, granular insight into individual users and all your various workspaces, and where that DBU usage is going, how much you're spending on running your various jobs. And then, ensure the right experts are overseeing your jobs in Databricks and your data pipelines. So really, this is shift left mentality. You put Unravel into your environment, you're putting the power in the hands of your developers, really to see at the beginning of the process what they're contributing to cost with the applications they're running, and allowing those experts to really take control and address those cost overruns right at the front, rather than 30 days later from leadership in some other part of the organization. So now we're going to jump into a demo, and we're going to show you how Unravel helps customers address the challenges that we just discussed. All right. So what we have here is the Unravel interface. And you'll notice there's a couple tabs up here where we talk about clusters. Cloud clusters is we're going to identify your interactive and your job clusters. And then the jobs themselves, if we want to go in and look at Spark context and see all of the various information that we can look at around your Spark jobs. And then the other one we'll talk about here is auto actions. This is where we get into sort of the governance aspect. But if we jump into, let's go into the cloud clusters here specifically. Now, what you'll notice is over the last 90 days, we're going to track all of the various clusters that have been running. Those could be your interactive or your automated, also supporting automated light versus your standard automated. Being able to track those clusters down to the various statuses, how long that they've been up and running, what users associated with the cluster and the workspaces they're running in, as well as various other tags. Now, when we talk about optimization with Unravel, the fastest way to get to optimizing your jobs is we're going to come here to our clusters. We are going to go into this inefficient tab, And right off the bat, we're going to pull up all of the clusters that have been tagged with some kind of an inefficiency that our AI has discovered just by watching the jobs run in the environment. In cases where we have specific tuning insights that help you optimize those jobs and make them run faster, use less DBU, you're going to see icons over here that are going to give specific tuning suggestions. Now, what we can do in our environment is using this inefficient tab and looking at these events. I can now look at any specific event that's maybe low-hanging fruit that I want to go address across the environment. So node downsizing events. Show me only the clusters that have node downsizing events. What you'll notice is kind of interesting here. When we talk about cost optimization and optimizing your jobs to effectively get that cost down, a lot of what you see on the screen, these are successful clusters. When we talk about automated, this is typically going to be your job running on its own cluster. All these are succeeding. So a lot of times you might look at a successfully running job and just say, hey, that's good enough for me. We paid for it. It ran. It did what it was supposed to do. But the real question is, did it do it in the most cost-effective manner? So if we come over here and we look at the Spark context for that application, there's a lot of information we can look at that's going to help us optimize the jobs. We can look at resources that were used for running the jobs. We can drill into each of the jobs that ran as part of this application, look at the various stages that occurred, how many tasks were executed, what was the code that executed in these tasks, how long do these tasks take to run. So we look at our timelines, if we have skewing events, etc. But really, you don't have to worry about all of that to quickly optimize, because one, you're going to see here how much did your job cost. And then we can come down here in our analysis tab. And we're going to identify with our AI various things based on all of that information that you can get from the screen, as well as from the sensors that sit side by side with your jobs and look at your application from a code level. But you'll notice this efficiency component in the analysis. So when we look at your application and see what you're doing as far as utilization around memory or CPU and the instance types that you've allocated to this particular cluster, without impacting SLAs, we can then give you feedback on what would be a more appropriate instance type to use for either or both your driver and your workers. So in this case, you'll see that we can downsize on our memory to a smaller instance type for both our driver and for our workers in our application. That's effectively going to give us a lower cost per hour, use less DBUs, and at the end, pack more jobs into what you've already paid for, those precious DBUs that you've bought from Databricks. And then you can take this further and you can apply this also to interactive clusters. So if I have jobs that are running together in an interactive cluster and we see additional insights that might point out that we're having some kind of resource contention in that cluster, CPU or memory wasn't available, you can see that in your analysis as well. And then I'll give you some information on how to right size your interactive cluster. Some of the other things that can potentially impact the costs of running your jobs, data skew, right? Because data skew is going to make your jobs much more inefficient because tasks may run longer than they need to. So you want to correct that skew. So again, we can quickly come in here in our bottlenecks. We can see where we have skewing taking place. In this case, in our Spark queries, you'll see that we are seeing things taking longer in our shuffle stages in these queries, pointing out specifically in what stage this is occurring in and what are the functions that are involved. So quickly allowing you to narrow down where you need to make these corrections. Contended driver is another thing where we can see a lot of time being spent on a driver, and then that can lead to, is your driver maybe you have a driver that's sized too large to handle the scenario. Let's offload some of this work to executors and adjust what our instance types should be. And then as usual, a very common scenario that we find, right, is, again, can our job be executed on a cluster using smaller instance types, still matching the same SLA? So when we act on all of these analyses that come back, apply these to our jobs, you're going to start seeing savings. Now, to quickly see those savings at a more holistic level for all of your environments, we can come in here and we can look at a couple things. We can look at usage trending. And usage trending is going to allow us to look at, either by workspace or by a particular user, and do that on across all of my clusters, or maybe a specific cluster. So in this case, we're just looking at our filter by workspace. We're looking at all clusters. And when I come down here and I look at this, I can see all of my workspaces and how each one of them is trending over time. So this is the number of clusters that I have in my workspace. But then more importantly is DBU usage. So while I see, cluster count considerably, up and down over time, if I tried to equate this to cost, I might just think it's the same graph, the same usage trend. But in reality, most of our DBUs actually just occurred on this one day. And it was in this particular workspace, our data science team. So now I can very quickly, across my whole environment, narrow down to maybe particular teams or particular users that are utilizing all of my DBUs, and maybe when they're using those DBUs. And if I know a particular date on when that occurred, I can also narrow that down to a particular activity and justify why that happened. Now, if we go to Chargeback, sort of a similar concept, right? I want to look at actual costs. So in here, we look at Chargeback by clusters. Again, I want to look at all clusters over the last 90 days, and I'm going to group this spend by users. So I can see now which user is responsible for most of my clusters. So I can see here that Gary is responsible for over 50% of the clusters that we spin up. But more importantly, he's responsible for almost 85% of our DBU usage, which is also responsible for getting close to 85% of our cost. So again, I could just assume that because somebody is spinning up a lot of clusters, that the cost is equated to about the same, but it's not. Only roughly half the clusters, but getting close to almost all of the spend. And I can see that breakdown here as well. Cluster count, DBU, cost by user. And if I wanted to drill into Gary, see which workspaces he's actually running his applications in, well, this is a reason we saw that spike in our data science workspace. Because the person that's running most of the clusters, or a good portion of the clusters, but accounting for most of the spend, is operating in that workspace. And if I want to see what are the jobs that he's actually running and on what clusters, I can see all of that here, as well as the DBUs related to each of those jobs. So we're giving you a granular, very quick feedback across your environment on how your development teams are utilizing your resources, so that you can nip problem in the bud before you get to the end of that month. And this is going to help you start to trim a lot of that fat off of what you're running today, make your processes much more lean, and as I mentioned earlier, improve the density of those resources that you paid for. Run more jobs in the same amount of DBUs. The last part to this is going to be auto actions. So auto actions, we can set up policies that look at jobs that maybe are running too long. So I don't want to have somebody spin up a cluster and, run a job that's longer than, almost 14 hours, right? So put in 50,000 seconds, we're getting close to 14 hours. If I see somebody running a job longer than 14 hours, please alert me. Any job at any cost. And that's the other thing we can look at as well, right? It's not just the duration of a job, but if I want to track jobs on what they're potentially charging me, and I have people spinning up jobs in my dev environment that, are costing me $100 every time we run this dev job, and they're running it a lot, I might want to throw that in here and say, give me an alert when I see jobs that are running that are costing over a certain threshold, so we can start taking actions on that. So with auto actions, that gives us the ability to provide that automated governance, that automated real-time visibility without having to assign people to go in and look at what's running in the environment and manually take that process. The last piece to this insights overview, this is a new piece to our product. Get a little preview of it here. But from this insights overview, this value dashboard, if you will, we can get a pretty good idea of the landscape and what we have from a cost perspective. If we have resource efficiency problems or areas where we can improve app acceleration. And as we've discussed, app acceleration and resource efficiency feed right into cost. But just at a high level, if I want to see right here, over the last 30 days, what did I spend on my all-purpose clusters or those interactive clusters? What did I spend on my automated clusters or my job clusters? How many of them contributed to that cost? And what does that look like over time, over those last 30 days? Here we see it going down, but more importantly, I might see a scenario where it's starting to trend up. And I want to know that, and I want to drill in, going back to that cluster's chargeback breakdown and the resource usage or the cluster usage, narrow down into who is responsible specifically for why these charges are going up. Get ahead of that before it eats your company alive. From those cluster insights we talked about and those job optimizations. So here we're talking about instance type recommendations across all of the clusters. So again, that holistic view. If I were to act now and go through and clean up my environment and all the job clusters we have configured, or those interactive clusters that are running all day, and I made those changes on instance types, what could I potentially save in making those changes? So, know if those changes are going to be worth it ahead of time. Look at, the top groups that are contributing by cost. So I can say, hey, my production environments account for the second highest listing of cost. My data science workspace, that's also up there. We have those auto actions that are looking at applications, and we have a rule that's looking at cost. How many of our applications across our environment are exceeding those cost limitations, or those, if everybody's just running a bunch of applications and we constantly keep spending more than we've allocated for this, we want to know that ahead of time so we can address it before it becomes a problem. It's going to also help you in forecasting. If you need to add DBUs, this helps aid in your conversations when you go back to Databricks and purchase more DBUs. What are you really going to need? Let's make sure we don't overspend ahead of time. And then here I can also look at my top clusters by cost. So not just the whole workspace, but now inside of this data science workspace is probably where specific clusters are contributing to that large amount of spend. So I can narrow that down and get that immediate visibility, that centralized insight from this dashboard. So with that said, We've talked about the vectors of cost optimization that occur at the job level, how we can then optimize those clusters based on instance type recommendations. Auto actions that allow us to do that governance, that visibility over our Databricks estate. And we went through a demo showing you the product on where we do that, how we do that. If you're interested in giving this a try in your environment, really quick and simple way to stand this up. We can do this through our SaaS free trial. We do, just go here, you sign up for your account and connect it up to your workspace. We'll start looking at all your clusters. There's a couple other configurations there, very easy, simple instructions that we provide to help you get stood up. 5-10 minutes, you're going to start seeing results in your account where you can make your optimizations, start understanding that cost visibility. So with that said, I'm going to open this up for any additional questions that you might have from what we talked about today.
Thank you, Patrick. We do have some questions for you that came in from the questions box. Are you ready?
Sure.
All right. The first question is, do you support Databricks on all cloud providers?
Yeah, so from that perspective, today we support Databricks running on Azure. That was sort of our first entry into the market there. And now we support Databricks with AWS as well. GCP is next in line. That should be supported in the near future. Don't have a specific date on it yet, but do look for that to be coming out soon.
Awesome, thank you.
Mm-hmm.
The second question we have here is Unravel only available as a SaaS product?
Good question. No, so SaaS is a quick and easy way to get it stood up. But to be honest, in a lot of our scenarios, we have organizations that don't want to use Unravel connecting into their environment. So we actually have an option for deploying on-prem. What we'll call on-prem, it's really installing in your cloud, essentially in your VNet, in your VPC. But basically, it's an Unravel server that you would stand up in your own virtual network in your cloud account. And we have no connection into that. There's no phone home from the server. So once it's in your environment, that is completely isolated in your environment. So from a security or regulatory concern, it's all self-contained inside your organization. So yes, we do have a non-SaaS version as well.
Thank you. It sounds like there's benefits of both.
Yep,
good to know.
Certainly.
All right, and then the last question we have here, before I read it off, I'll just give one last shout out. We do still have some time if you're listening to drop your question into the chat, into the questions box. All right, and then with that said, the last question we have here is, can Unravel see clusters in all of my workspaces or just a single workspace?
Yes, another good question. So in Unravel, you actually can connect as many of your workspaces as you'd like. And it doesn't even have to be in the same account. So if you have multiple, let's say I have multiple accounts in Azure and multiple workspaces on each of those accounts, but I have a centralized team that's sort of responsible. Maybe it's a cloud team or a platform team for Databricks, what have you. In a single Unravel instance, we can connect across all of your accounts, all of those workspaces, and then bring in all of that cluster information and your jobs across your whole estate. So yes, not limited to a single workspace. You get full visibility across the board.
Great, thank you.
Mm-hmm.
And those are all the questions that we had, and that is all the time that we have for this webinar. So I just wanted to remind everyone that this is instantly available on demand. So please share this link with your colleagues or peers. And if you are watching on demand, thank you for tuning in. If you'd like to ask us a question, please email us at hello@unraveldata.com. And again, we value your feedback, so please share your thoughts by rating this webinar and letting us know if there are any other topics you'd like to hear about. Of course, I'd like to thank Patrick for sharing his knowledge today and you for your time today. We hope to interact with you at future webinars and events, so keep an eye out for our next optimized webinar on managing costs for Amazon EMR. Thank you, everyone. Patrick, any closing thoughts?
Yeah, I guess I'll throw one out there. Hopefully everybody got something good out of the presentation today, but I really want to, again, encourage everybody to go out there, sign up for a free trial, be the hero of the day for your organization, save everybody some money. And as Marissa said, come out and see us wherever you find us at your favorite locations. So yeah, thank you for allowing me to present today. And I do hope to see some of you out in the community soon.
Thank you, Patrick, and thank you, and have a good day.